Okay, let's see if we can do some ALEKS homework on determining whether a precipitate forms when two things are added together. And the ALEKS problem gives us three different things, three different situations, and so let's just sort of take care of these one by one here. So in the first one, the first solution that we have here, iron chloride and potassium hydroxide. So is a precipitate going to form, and if it does form, what's the formula? The empirical formula for that. Okay, so we should actually just do the chemistry. So let's go ahead and write down iron 2 chloride. So iron 2 chloride is FeCl2 plus potassium hydroxide, KOH. They should tell us, and they do, that these are both aqueous. Okay, this is aqueous as well. And so what are the products of that going to be? And so the products are going to be, if you remember, iron is going to come over here and go with hydroxide, and potassium is going to go with the chloride. And so my answer for this, for the chemistry, is going to be FeOH2. You have to remember the hydroxide is a -1 plus KCl. Alright, we need to balance this. So always balance, and so I think if I put a 2 right here, put a 2 over here, so that should balance things well enough for me, and they do. Now the question is, does a precipitate form? Does the iron hydroxide form a precipitate, or does the potassium chloride form a precipitate? Well, the only way you're going to answer that is by looking at a solubility table. I kind of like the one that our homework has, and so let's go ahead and pull up a solubility table. It looks something like this. And so the two things that we're interested in are KCl. We're also interested in the high iron hydroxide. Okay, and so if we look at potassium, so let's find potassium. Potassium is right here. If I look across the whole row over to here, everything that associates with potassium is soluble in this solubility table. So if it is soluble, it does not form a precipitate, so the KCl does not form a precipitate. Now let's go find the iron 2. Iron 2 is right here. If I start going across, all of a sudden I find that when I get to the oxide, right here, or if I get to the sulfide, or if I get to the hydroxide, it is not soluble. So this will form a precipitate. And so if I go back to my problem here before, then you'll see that this, the iron hydroxide, if I can bring up my pen, the iron hydroxide does form a solid, while as the potassium chloride is aqueous. Alright, so if I was to write the empirical formula for that, then I would write FeOH2. Let's tackle the next one here. Okay, I'm going to thicken up my pen just a little bit here so I can see a little better. Okay, so the next one is sodium hydroxide, NaOH, plus ammonium bromide, NH4Br. Okay, what is that going to do? These are both aqueous. So it's aqueous. This is aqueous. Alright, so let's just kind of do what we always do. The sodium is going to go with the bromide. The ammonium is going to go with the hydroxide. And so if I write this out, it would be NaBr plus NH4OH, ammonium hydroxide. Okay, the question is, do these form precipitates? Well, the only way you can tell is to go back to your solubility table. So I go back to my solubility table right here, and forget my species, the ammonium hydroxide and the sodium bromide. So everything with sodium. So you might be able to answer this one really quickly. So everything was sodium right here. If I look across that whole row over to here, everything is soluble. And with ammonium, everything is soluble except for the oxide. Well, we weren't looking for that. If we go back, then it is ammonium hydroxide and sodium bromide. All of these are aqueous, no precipitate forms, just by looking at the solubility table. And so the answer here is going to be no. Last one. If I have iron 2 chloride, FeCl2, plus zinc nitrate, ZnNO3, 2. Those are aqueous, the problem tells us. Let's say aqueous, and this is aqueous. So what are they going to give us? Again, pardon my writing is terrible on this thing. So that was going to give us FeNO3, 2 plus ZnCl2. Okay, that should get it to us. I think everything is balanced here already, so that is good. And the question is, are these soluble or do they form precipitate? So iron nitrate and zinc chloride, you got to go back to your table. So iron, if I go across iron 2, I keep going to the nitrate, which is at the end. The iron nitrate is soluble. That's not going to form a precipitate. The last one is going to be the zinc chloride. Let's go find zinc on here. Zinc is right here. If I go across zinc chloride, it is soluble right there. So if I go back to both of these are going to be aqueous. The iron nitrate and the zinc chloride. So again, on this one, no precipitate is going to form. So how do you figure out if there's a precipitate? When they give you two solutions, do the chemistry. We did that in class. Find out from the solubility table if these that are formed from a double displacement reaction, these species, find out if they are precipitates by looking at the solubility table. That's the only way that you're going to find that out.